This is lesson 3.8, entitled Rewriting Equations and Formulas. You should be on page 184. This is going to be probably the first time this year that one of the vocabulary words in our book we're not going to need to know. Literal equation isn't something on a Common Core standard level we need to know, so we're not going to cover that. We'll just move forward from that. It's not going to hurt anything. You're not missing out on anything. So any of the literal equation questions in the book work I've also exempted from you doing, all right? However, we are going to rewrite equations and formulas. Now, we will rewrite equations that have two or more variables. I will talk about that here in a minute in my video, so you might want to put, we will work on two or more variables, solving equations with two or more variables. I will definitely have you rewrite an equation so that y is a function of x, and we better put a little note on that. When you read this wording, write an equation so that y is a function of x, here's what this wording means. It means isolate y on one side of the problem. I'll show you how to do that. Now you notice they did that for this. We'll walk through problems like this in a minute. But you notice how the answer, y, is on one side of the problem all by itself. Do we understand what the word isolate means? Isolate means get y all alone on one side of the problem. So I did. Y is all alone on one side. You know, my other terms and my constants and my coefficients and so on are on the other side. So we'll walk through how you do that in a minute, but right now make sure you get in your notes that when you see this wording for directions, that wording means get y on one side of the problem. You will also solve and use geometric formulas. So again, same thing, we're going to have to be able to isolate a variable on one side of the problem. Let's actually work through some examples of that. Work through some examples, wrong page there. All right, so let's go to the bottom of that page, page number 185. They have a few problems that we can do these very techniques and show how we accomplish that with these two. So let's do number 3. It says write this equation so that y is a function of x. Now remember, this wording means get y by itself. Okay, so let me write the problem up here. I have an open space, and you can write this in your notes. 5x plus 4y equals 20. Let me draw up my onion. I am trying to isolate, I want to get y by itself, so y is the center of the onion. The times 4 would be the next layer. This 5x out here is the outside layer. Now remember, that 5x would have a plus in front of it. I got to get rid of plus 5x first, so I'll take that away to start. I'm subtracting 5x from each side. Okay, now be very careful. Are these like terms? Can I take 20 and subtract 5x and make it 15x? I hope you're saying, wait a minute, Mr. Lemansky, that's screwed up if you do that. You're right, it is screwed up. I can't combine those together, they're not alike. So all you'd write on paper is, okay, I'm taking 20 and I'm subtracting 5x. Now, next layer of the onion, I got to get rid of the times 4. So I'm going to divide by 4. And you might remember this from earlier in the year. We did these type of problems in Chapter 2 where, okay, let's simplify. Let's break this up into separate fractions and let's reduce each fraction. Well, 20 divided by 4 is definitely 5. 5 divided by 4, there's no common factor. I'll just leave it as 5 fourths x. There you go. I just rewrote this equation so that y is a function of x. So this would be the answer to problem number 3. I just rewrote the equation so that y is a function of x. Let's do another one. Let's do 4. The perimeter P of a rectangle is given by this formula. I'm sure you've seen that formula before, where L is the length and W is the width. solve the formula for W. When you see that, it means get W by itself. All right, so let me write this over here. And again, I'm thinking onion right now. I want to isolate W, so W would be the center of the onion. Now, the times 2 would be the next layer. The outside layer would be the 2L. Now, there's no sign in front of 2L, which means it's a plus. Well, how do I get rid of plus 2L? Well, the first step would be I got to take it away from the right of the equal sign and the left. Now, remember, those aren't alike. P and 2L are not alike, so just write P minus 2L. I can't combine them into one thing. And over on the right side, I have 2W. Okay? Next layer of the onion, I got to get rid of times 2, so I'll divide by 2. So W would equal, let me break this up into separate fractions again, P over 2 minus 2L over 2. Now look right here, can I divide 2 by 2 and call those ones? So I ought to end up with, the width would equal perimeter divided by 2 minus the length. That would be the correct formula solved for W. Now it says, use the rewritten formula to find the width of the rectangle shown. Well, this should be easy now. The perimeter is 19.2, so I'll plug that in for P. So for part B, I'll plug in 19.2 for P, so I have 19.2 over 2, and I'm going to subtract the length, which is 7.2, and this should equal my width. So let me put that in my calculator and try it real quick. 19.2 divided by 2 minus 7.2 is giving me 2.4. My width for this problem should be 2.4. Let me check it real quick. So if this is 2.4, that would mean that the other side is 2.4 also. 2.4, and this would be a 7.2 up on top. Let me add those four sides together real quick and see if I get 19.2. So I'm doing that, 2.4 plus 7.2 plus 2.4 plus 7.2 in my calculator. That is giving me 19.2, so I know the answer has to be 2.4. Let's look at one more. They have one of these questions where we have to use the Celsius formula. Okay? It says you're visiting Toronto over the weekend. A website gives the forecast shown. Use the low temperatures for Saturday and Sunday. Or, I'm sorry, find the low temperatures for Saturday and Sunday in degrees Fahrenheit. Use this formula where C is the temperature in Celsius and F is the temperature in Fahrenheit. Well, I tell you what, since I want to find Fahrenheit, let's solve the formula for F. Let's get F by itself. So let me write my work over here. I got an empty space. C equals 5/9 F minus 32. Let me draw my onion. F is the center. The minus 32 is the next layer because minus 32 is in parentheses. The times 5/9 is the outside layer. So my first step, I got to get rid of times 5/9. I'm going to divide by 5/9. Okay? So these cancel. Now, over here, didn't we learn earlier in the year that dividing is the same as multiplying by the reciprocal? So the dividing by 5/9 would be the same as multiplying by 9/5. So I'm going to write it that way. I'm going to take C and I'm going to multiply it by 9/5 because that looks nicer. That should equal F minus 32. Okay, next step. Let's add 32 to each side, and my Fahrenheit temperature should equal 9/5 Celsius plus 32. So I just rewrote the temperature for Fahrenheit. Now, after that, do you see how the low temperature on Friday is 13 degrees Celsius? It ought to be really easy for me just to plug a 13 in here, and let's find the temperature in Fahrenheit. So I'm going to do that real quick. 9/5 So open parenthesis, 9 divided by 5, close parenthesis, times the 13 degrees Celsius plus 32. It looks like in Toronto on Friday, the low temperature would be 55.4 degrees on Friday, okay? So the Fahrenheit temperature would be 55.4 degrees on Friday if I use that little formula. And then I could also find the Saturday and Sunday temperature in the same way, okay? If there's any questions over the video, make sure you ask during class time.